Hello, so we have come again. Find the derivative of y equals square root of x from first principle. So we'll proceed very quickly. Y equals square root of x. So we go with y plus delta y equals square root x plus delta x. So of course whatever happens to x happens to delta x. Alright, so what do we do? Next is to make delta y subject formula, and that's going to be y plus delta y minus y equals square root of x plus delta x, and also minus y. As it is to the left hand side, it has to be for the right hand side. And then y minus y cancel out, you'll be left with delta y. That's equals to square root of x plus delta x minus the equivalent of y from the question is square root of x. Now, when we get to this point, it is expected of us that we are going to simplify this right hand side, of course. Now, in simplifying this right hand side, it's not going to be the normal way that we have been doing before. Now we have to introduce, this looks like a surd, and there is a concept we call the conjugate of surd under the topic surd. Conjugal bliss forever. Alright, don't mind me, that's just on a lighter mood. And what is surd and what are conjugates of surd? Surd are concepts that have what root signs like this. And then if they give you something like this, probably square root of 5 plus 11. What's going to be the conjugate of square root of 5 plus 11? Of course, it's going to be square root of 5 minus 11. That's going to be the conjugate. So if this is the surd, this will be the conjugate. And if this happens to be the surd, this is going to be the what? The conjugate. So we are going to apply the concept of what? Conjugate of surd. So we are going to look for the conjugate of this right hand side, and we are going to multiply the conjugate by this concept. So we are going to have this dy or delta y rather is going to be, we open a bracket, square root of x plus delta x for this first one, now minus square root of x. This all have been enclosed in this bracket. So we are going to introduce the conjugate, and that's going to be square root of x plus delta x. Now, in the place of minus there, it's now going to become plus root x, and that is the conjugate of this one. So the conjugate of this is this. So what do we do? Because the conjugate was not there before, we have to look for something that can deal with this conjugate to come under, and it's just going to be exactly that conjugate. So that's going to be square root of x plus delta x, and then plus root x. And I'm sure you will agree with me that this one under here can easily cancel this one on top here, and when they cancel out, it's just going to be what? 1, 1 in each case. So, and 1 multiplied by this is going to return us to what we have here. So what's the essence of introducing this one at the denominator? So that you can still know that everything that we have here under is the same thing as everything that we have in this line. So this line is not different from this line, only that we have to bring it from this format to this one so that it can be something that is what? Workable. And this is what we can work with. Alright, so we have this already. And when you multiply a surd by its conjugate, what happens? It's just difference of two squares. Just like when you have a plus b multiplying a minus b. When you expand these two brackets, you are going to come up with a squared minus b squared. So we call this difference of two squares. This is one square, this is another square, and in between them is a minus sign. So that minus sign, the result it gives to us is what? The difference of these two squares. And when you are going to simplify difference of two squares, we are going to put them in brackets. This is what it gives to you in bracket form. Alright, so we are going to be applying that idea in this also. So this is just going to be like a minus b multiplying a plus b, and of course all we need to do is to square a as we have it here, and then square b as we have it here, and what is going to be between both of them is going to be just what? Minus. Okay, so I'm bringing it up here. Now, in squaring our a, which is this one, we are going to have it to be root x plus delta x squared, representing our a, minus root, sorry, that's not what I'm supposed to have. We are going to have delta y equals root x plus delta x squared, which is representing our a here, then minus root x squared, which is representing our b here in this case, and everything is going to be over root x plus delta x and then plus root x for the denominator. So explain this. This numerator, when you multiply out these two numerators, this is what you are going to come up with. Difference of two squares. And then the denominator remains as it is, unchanged. So we come under to have this. Delta y will now be equals to, when you square this one, of course, this square is going to deal with this square root, and you'll be left with x plus delta x minus, this square also is going to deal with this square root, so you are going to be left with only x, and the denominator remains root x plus delta x plus root x. So I'm going to be writing the equal sign and be simplifying this one so that we can maximize this little space that we have remaining. So x minus x will be gone to become 0. So we'll be left with delta x for the numerator over root x plus delta x plus root x. So that is what delta y has turned to. This is the simplification of the right hand side of delta y. So we have simplified it. So the next thing to do now is to have delta y, over delta x. That's dividing through by delta x. And when we have that, so it's going to be delta x over root x plus delta x and then plus root x. Now, because it is to be divided by delta x, so I'm going to multiply it by 1 over delta x. And of course, delta x here 1, delta x here is what? 1. So what are we having left? Delta y is going over delta x becomes equal to 1 over root x plus delta x and then plus root x for the denominator. So we have also simplified delta y over delta x. So the next thing to do now is to introduce our limit, and limit delta x to 0. So we are going to have limit as delta x tends to 0 for delta y over delta x. That's going to be equal to, for the right hand side also, limit as delta x tends to 0 of 1 over root x plus delta x and then plus root x. All of this make up the denominator, and then we enclose our bracket. So when we limit delta x tending to 0 for the left hand side, of course we are going to have what? Dy by dx as the equivalent. That's equals to, so wherever we see delta x on the left hand, sorry, the right hand side, we are going to be introducing 0. So that becomes 1 over root x plus 0 in the place of delta x, and then plus root x. So simplifying this one further, we are going to have 1 over root x, because x plus 0 is x, plus the second aspect also root x. And eventually it means that our dy by dx, dy by dx will be equals to 1 over root x plus root x, of course, is going to give us 2 root x. That is the derivative using first principle. So this is one way to represent it. Another way to represent that is this, or using the laws of indices to simplify, we are going to have it to be 1 over 2 x raised to power negative half. So either of these two solutions is acceptable